Okay, guys, welcome to another class period lecture. This one is titled, again, How Do Scientists Answer Questions and Apply Their Findings? So really what we're doing is a continuation of the last last lecture, where we talked about scientists kind of communicating what they found during their experiment. So yeah, this one is part 2. Notice how it says Unit 0, Week 2, Day 4 and 5. It's a continuation of the last lesson. So your objective for today is that you will be able to recognize different types of graphs, that you will be able to create an appropriate graph to represent your data, and that you will be able to construct a statement based on the analysis or looking at a graph. And so we will do the do now in class. So make sure you have a notebook or piece of paper and pencil. You can take notes in your class notes on your OneNote on Microsoft Teams, however you'd like to do this, but we need to title it as types of graphs for part 1. So there are several different types of graphs. These are definitely not the only ones that are out there, but these are the types of graphs that we're going to use most often in our class. So the first type is a bar graph. Notice how, let me get my little pointer. Oops, where'd it go? Okay, well, notice how the bars are individually individual of one another. They're not connected. There's no connect the dots type deal as in a line graph. These are completely separate. You would use a bar graph to compare things like between different groups to track changes over time. Okay, so this would be like group 1 made this many baskets, group 2 made this many baskets, group 3, group 4, group 5, and group 6. Okay. A line graph is used to track changes over a short or a long period of time. Okay, so again, we're tracking one thing as opposed to multiple things in a bar graph. We're tracking one thing across time. So how many people there were in the United States in 1999, 2000, 2001, 2002, 2003, 2004, and so on. Again, this is all representing one place, the United States, over the course of time. So we would make a line graph. Then we have pie charts. Pie charts are best to use when you are trying to compare parts of a whole. They do not show changes over time. Okay, so if I wanted to take like a poll, we've done a couple of those in class. If I wanted to take a poll about how you're feeling, let's say green represents happy. So a certain percentage of the class is feeling happy in that moment when we asked you to take the poll. A little sliver, let's say, I think that says 6%. 6% feels, anxious. And then this yellow area, let's say it's 23% feels overwhelmed. So we could basically create categories and ask people to take a poll or a quick survey of how they're feeling and get a pie chart, which shows me how they feel in that moment, not necessarily over time. Okay. And it shows the entire one group. It's showing it as one group. Then we have a scatter plot. We're going to see these very rarely in this class, but we do see them, not necessarily on tests though. So scatter plots are used when you want to show a relationship between multiple variables. Again, this is a little more advanced. We're talking, physics class or chemistry class. So I'm not going to go into too much detail with the scatter plot. But again, we're just showing a relationship between multiple variables. Okay. Oh, and With a scattered plot, you're looking at trends, right? There's a lot of dots here. We would look at an overall trend through the center of that scatter plot. So, how do we create these graphs? Okay. Um, um, so, there are four main things that all graphs should have. You will get marked wrong on a bunch of homework or test assignments, um, homeworks, quizzes, or on a test if you do not have all of these parts. These are key to any class that deals with graphing, whether that's history class, whether that's science class, whether that's math class, whatever the class is. If you're making a graph and you don't have these four key components, it's not, you're not creating useful, meaningful, appropriate graphs for your class. So, first things first, all graphs should have a title. All graphs should always have a title. So, for this graph, we have visitors at the park. Okay. Number two, all graphs should have an X and a Y axis. So if you've ever, taken a math class, you already know this, okay? But the X axis is horizontal or laying down at the bottom, and the Y axis is vertical or up and down on the left-hand side of the graph. In this class, you will never put um, the the y-axis on the right side. There are some graphs where you have numbers on both sides. We're not necessarily going to deal with that in this class. This is very like fundamental basic. Okay. So the x-axis lays down horizontally and the y-axis is standing up vertically on the left hand side. Then we have our scale. This is where a lot of students really have a hard time. The scale are the numbers going across the x-axis and the y-axis. Okay, there are multiple reasons why the scale is really important. The scale makes sure that you're, one, using the entire graph, okay, and two, making sure that you are representing your data accurately. Okay. If I just draw lines, oh, I think in 1995, the number of visitors was less than in 1996. Well, I could draw two lines that are different sizes, but that doesn't reflect my data. Again, the only reason I have these numbers is because I did the research or I ran an experiment where I took those actual numbers. These numbers have to be accurate. The other problem or the biggest problem that students have with creating scales is they don't number them correctly all the way through. Like I said, a scale makes sure that you use the entire space of the graph, okay? So that you don't have a tiny graph that only goes, to here and you can't really see everything. Okay, so it's important that you create a graph that uses up all of the little tick marks. So that's going to take some like math. Um, and so we'll work on that a lot in class. Um, but it's really important about spacing your scale as well as numbering correctly. Again, spacing the numbers out so that the entirety of the x-axis is used and spacing your numbers out so that the entirety of the y-axis is used. Okay. If I wanted to, I could have gone like 0 to 70 here, but then I would be only using one space and all of them would be kind of, super here at the bottom, and we wouldn't be able to see the actual differences within the years. So please, please, please make sure that you are paying attention to the scale. This is a big one. And finally, a legend. A legend generally describes like the colors used. So if these were different groups, let's say this was like Pacific Islanders, Caucasian people, African American people, Latino people, and so on and so forth. We could use different colored bars to represent those different ethnicities. And then we would need a legend to explain that purple meant Pacific Islanders and green represented Latinos, and, just um, an explanation box is a legend. Okay. We also make sure that we, in parentheses, always put the way that we're measuring our independent and dependent variables. We'll talk about that in a minute again, but notice it says number of visitors in thousands. Okay. So 10,000, 20,000, 30,000 people in 1995. And it explains that it's the year. We don't have to put any more detail than that there. Okay, but it's a super, super important step that a lot of students miss. Probably the hardest part of graphing, honestly. Okay, so again, I just highlighted the X and the Y axis. The Y axis is standing up vertically. The X axis is laying down horizontally. Now, this is another big part of creating meaningful graphs, okay? The dependent variable, what you're measuring, always goes on the y-axis. The dependent variable, or what you are measuring, always goes on the y-axis. Your independent variable, or what you are changing, is always going to go on the x-axis. So if I go up to our example in the last slide, I have number of visitors. That's what's changing. So that is the dependent variable. And the year is I'm sorry, I said that incorrectly. The year is what is changing, right? 1995, 1996, 1997, 1998, and 1999. That's our independent variable, just as we saw here. I'm sorry for that mistake. Okay, our independent variable is here. Independent variable, what's changing? We're changing the year that we're recording our measurements. The number of visitors is what we are measuring. Again, sorry for that mistake, is what we're measuring, and therefore that is the dependent variable on the y-axis. Okay. So we already talked about the scale. That's really important. Again, the scale, the scale at the bottom as well is also just as important. And then, finally, we talked about the legend. Again, the legend is explaining the different colors that are used or different titlings. Okay, so just as a little review, what did we talk about? You need to choose what type of graph you're going to use based on the descriptions that I gave you. You then need to create a title that is representative of your findings. It cannot be ambiguous. It needs to be straightforward and to the point and should not be very long. You need to label the axes, okay? First of all, as independent and dependent variables, and then create a scale using the numbers or the data that you collected. And finally, chart the values. So we haven't gone over actually charting the values yet. If you've taken a basic math course, you should know how to do this, but I will review it here. So I have a data table. Normally you will get your data in some form like this, okay? And it says student number and credits completed. So for a freshman, you obviously don't have that many credits or any credits completed because the first semester isn't over yet and you haven't gotten your grades. But you would normally start with a graph that's blank, and your job then is to follow the steps to creating a meaningful representation of this chart. Okay, so you're basically taking this chart and you're putting it into a picture form. The first thing you need to do is come up with a title. Okay, so we could title it Student Credits Completed, Credits Completed by Students, you name it. So I'm just going to go in here and credits completed by students. Okay, and then once I have my title, then I'm going to start thinking about what is my scale, what is the independent and dependent variables. So here we have student number and how many credits completed. We're not talking about there's one student, there's two students, there's three students. No, we're talking about this is student number one, this is student number two, student number three. In total, we are measuring how many credits 5 students have completed. Okay. So students and then credits completed is what we're measuring. Okay. So we're changing which student we're talking about. So that's our independent variable. And our dependent variable is how many credits they have. Okay. So if you see here, if the slide will change, okay, student number is our independent variable and credits completed is our dependent variable. And I put them there. Okay, so again, we started out with our blank slate. We created a title. We then wanted to put our independent and dependent variables in the correct positions. And so I've gone ahead and done that. Student number at the bottom, credits completed. On the y-axis on the left-hand side, I created a scale. Notice how I'm not using the entire graph, but it's as close as I can get without going over it. So I have, let's look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 lines, and I need to fit 20 credits. So that wasn't going to fit going by ones. So I decided to go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, which is going to use up the majority of the graph. And it still gets in all of my numbers. Then I have 5 students, again with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different areas. So I just decided to go every 2. So, oops, mess that up a little bit. 1, 2, student number 1. 1, 2, student number 2. 1, 2, student number 3. 1, 2, student number 4. 1, 2, student number 5. That way their information is nice and spread out. We use the entirety of the graph and nothing's squished or out of place. Okay. So then all we would need to do is graph the points. So I'm going to, let's see if this will work. Okay, so student 1 had 10 credits. So student 1, I'm going to go here and I'm going to go up to 10. 2, 4, 6, 8, 10. I'm going to put a little dot there. Hopefully it works. Perfect. Okay, so as we can see, I have a point there. Student 1, number 1 has 10 credits. I can make this larger. Actually, you know what? That's probably not the best shape I could use. I could use a rectangle or something. Let's see here. This would actually be better. There we go. Bam. Nice. Okay. Student number 2 has 15 credits completed. So I'm going to do the same thing. Shape, whichever shape I just used. I can't remember. This one. There we go. Student number 2 has 15. Notice how 15 is in on my scale. Okay, but that's okay because I can go 2, 4, 6, 8, 10, 12, 14. The next one's 16, but if I go halfway between 14 and 16, that's 15. Okay? And then student number 3 has 20 credits. So I'm going to go ahead and do that again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Make it a little wide. There we go. Student number 4 has 12 credits. Boom, 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 boom. So I'm going to go up again. 2, 4, 6, 8, 10, 12. Bam. Done. Okay, again, just because I'm doing this on the computer, you could be doing this wherever you are with a piece of paper and pen. These could just be regular lines, okay? And finally, student number 5 has 18 credits. So I'm going to go one more time at the end here. 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 credits for student number 5. And then if I just go over and I copy, let's see, I'm forgetting my title, so that's important. I need to make sure it's on my completed graph here at the end. Credits completed by students. And so I have my title. Let's look at our checklist. We chose the graph type. I'm using a bar graph because I'm showing different groupings. I created a title. I labeled my axes by the independent and dependent variables, number of credits completed, and then student number here. I'm sorry, I'm showing you here. So number of credits completed and student number at the bottom. And then we created a scale going by twos so that we could use the majority of the graph vertically. And then we skipped every 2 lines to put the student number all the way across using the entirety of the graph. And finally, we charted the values, starting on the x-axis and going up the y-axis. Okay, so now I could use this graph to interpret my data, which is the next step. So interpreting your data is the next step in meaningful graph making. Okay, what does this graph tell us? You need to be able to tell your audience what your graph tells us. Okay, so the 3 things that you need to incorporate into your interpretation of what a graph means is the data table, which you just made into your graph, your text evidence, meaning what was a kind of like the written information that you gathered during your experiment, and then any inferences you have. So again, taking into account, hey, maybe there were a bunch of different possibilities for the answer to my question. Is my hypothesis correct? Yes or no? And if I was not correct, what other possibilities could my data be showing me would be the correct answer? Okay. So it's kind of taking all of these 3 things and including them in your conclusion when you determine what does this graph mean. Okay. You're taking into account the numbering, the text evidence from what you did, and inferences that could further your experiment or prove that you maybe were wrong, but you also proved that something else was right. Okay, I'm going to include another video where I go over some specific examples of graph making, just graph making examples, and then in interpreting one of the graphs example. So please also watch that before coming to class because I might give some answers away. So that's important. Okay, guys, have a wonderful rest of your day, and I will see you in class.